Welcome students. Today our topic is how milk can be processed before marketing. To ensure safe milk free from disease-producing bacteria, toxic substances and foreign flavors, fresh whole milk is to be processed before marketing. The process helps produce milk that has an initial low bacterial count, good flavor and satisfactory keeping qualities. Milk processing operations consist of filtration, clarification, homogenization, sterilization and packaging. Filtration and clarification of milk. Now, purpose. To remove the foreign matter, that is straw and hair pieces, dust particles, leukocytes, insects, etc. It also removes the gross impurities but does not remove bacteria from milk. Now the process. Milk is passed through a filter cloth or filter pad. The filtration medium has a pore size of 25 to 100 mm that permits most of the foreign matter to be retained on it. Filtration can be carried out either on cold milk about 10 degrees Celsius or warm milk about 40 to 45 degrees Celsius. Warm milk filtration is more rapid due to lower viscosity of warm milk. It's universally used. Now the clarification. Employed to remove insoluble impurities, especially the finer ones. It involves the use of a centrifugal machine called clarifier. Part of bacteria is also removed along with the extraneous matter. Now the process. Milk is subjected to a centrifugal force in order to eliminate the finer but heavier particles from milk, somatic cells, dust particles, etc. The heavier dirt particles are thrown out into the sludge space surrounding the discs where it's collected during the run. Raw milk is made to pass usually under a pump pressure down a central pipe of a rotating bowl and led to the outer edge of the clarifier discs through a distributor in the bottom, and then onto the spinning discs where milk and dirt are separated. Now the bacterifugation. Bacterifugation is particularly applicable to removal of bacterial spores from milk, which are difficult to inactivate by heat treatment and are heavier than vegetative cells. The bacterifuge is kind of high speed up to 20,000 rpm. Clarifier provided with a discharge nozzles in the bowl wall. The centrifugal force generated in it is up to 10,000 gravitational acceleration. The bacteria in milk being bacterifuged are collected in form of bacterifugate in the sludge space. The bacterifugate is approximately 3% of the feed volume and contains primarily bacterial spores and milk proteins. Anaerobic spores are removed to an extent of 98 to 99%. A double bacterifuge treatment at 73 degrees Celsius yields more than 99.9% reduction in bacterial spore count of milk. Application. Cheese making where removal of anaerobic spores from milk is useful in avoiding the problem known as late blowing in hard and semi-hard cheeses. To extend the shelf life of milk under refrigeration, clarified and standardized milk is bacterifuged at 60 to 75 degrees Celsius, followed by pasteurization employing the HTST process. Now the separation of milk. Separation of milk refers to separation of milk fat from milk. It enables the processor to manufacture a variety of fat-rich daily products such as cream of various types, butter, ghee, etc. Makes it possible to adjust the composition of milk with respect to its fat and SNF contents. Desired for product manufacture as to meet the legal requirements of different types of fluid milk. Methods of separation of milk. Two methods of separation of cream from milk are commonly used: gravity separation and centrifugal separation. Both these methods rely on the basic principle of separation of two immiscible liquids having different densities under the influence of gravitational or centrifugal force. Gravity separation Milk is allowed to stand undisturbed for some time. A layer of cream forms on the top due upward movement of the lighter fat globules in the heavier serum that takes place owing to gravity. Creaming may become evident in as short time as half an hour. The creaming rate will be maximum when the density difference is maximum and viscosity is minimum. This increase is particularly prominent between 10 degrees Celsius and 30 degrees Celsius and much less above 50 degrees Celsius. Cream separation by gravity is, however, a very slow and inefficient process. It is of little practical value for commercial purposes. Now the centrifugal separation. Centrifugal force is used as the driving force. Milk enters through the bottom of the separator bowl, holding a stack of conical discs rising up through holes located somewhere in the middle of the inner and outer edges of discs. The milk between discs is subjected to a centrifugal force in the rotating bowl and thereby tends to fly out from the center. The skim milk fraction, being heavier, moves away and forms a layer on the outer edge of the discs, whereas the flat globules gather on the inside edge. The incoming unseparated milk forces the separating layers further and upward out at the top of the bowl. There are two outlets in the cream separator, one for skim milk and the other for cream, the cream outlet being nearer to the center. The higher the speed of the bowl or larger the diameter of discs, the greater will be the separation rate. Now, standardization of milk purpose. The liquid milk sold in the market is of different types with regard to its composition. The compositional modification or adjustment is necessary if the milk is to be converted into a certain product. A product must conform to the legal standards prescribed for it or the quality standards set up by the manufacturer. Now the definition. Standardization refers to the process by which the milk composition, fat and SNF for market milk is adjusted to the desired level. For certain specific product manufacturing applications, even protein content may be adjusted. Standardization involves lowering or raising the level of a particular constituent to the desired value, especially fat. Standardization of milk for fat. Milk may be standardized to a certain value of a single component, that is fat or SNF alone. This can be achieved by adding to the milk a calculated quantity of a fat-rich product such as cream. If the fat level is to be raised, or a low-fat or fat-free component, example skim milk, if the milk has excess fat. The fat content of milk can be reduced also by separating a calculated amount of cream of known fat percentage. The calculation of the quantity of cream or skim milk to be added to milk or the cream or skim milk to be separated from it can be made by a simple method known as the Pearson's square method. Now the pasteurization. Pasteurization is the key process in modern dairy plant operations and forms an integral part of manufacturing of various indigenous and Western dairy products. Milk is a perfect medium of growth of microorganisms, and growth of pathogenic organisms can cause disease such as tuberculosis and typhus. Pasteurization kills the microorganisms and makes it safe for consumption. The word pasteurization has been named after an eminent French scientist, Louis Pasteur. In general terms, it's heating milk or its products to such a temperature which destroys nearly all the microorganisms present in it without affecting the composition or properties of the product. As per the definition of Internal Dairy Federation, pasteurization is a process applied to a product when an objective of minimizing possible health hazards arising from pathogenic microorganisms associated with milk by heat treatment, which is consistent with minimal chemical, physical, and organoleptic changes in the product. Time temperature combination 63 degrees Celsius and held at that temperature for at least 30 minutes. 72 degrees Celsius and held at that temperature for at least 15 seconds. The milk is then immediately cooled for a temperature not greater than 4 degrees Celsius. This means pasteurization includes heating to a specific time temperature combination followed by immediate cooling to 4 degrees Celsius. The most heat-resistant pathogenic organism at pasteurization temperature is the Mycobacterium tuberculosis, and hence this has been made as an index organism to achieve complete safety of milk. Any heat treatment which will destroy this organism can be relied upon to destroy all the other pathogenic organisms as well as other organisms involved in milk spoilage. Pasteurization has two additional benefits, that is, destruction of a large number of spoilage microorganisms present in the raw milk and deactivation of some natural enzymes like lipase, which can adversely affect the quality of manufactured products, that is, lipolysis or breakdown of fat into glycerol and free fat acid. Pasteurization is not a substitute for cleanliness during milk production. The pasteurization process should only be applied to raw milk obtained from healthy cow, which is clean, sweet and has a low bacterial count. Limiting factors for heat treatment. The upper and lower limits of temperature to pasteurization process are based on thermal death point of tubercle bacilli and beginning of reduction of the cream line. The thermal death time for tubercle bacilli provides the lower limit to heat treatment. The adverse effects on the commercial quality milk provide an upper limit for the possible time temperature combinations used in pasteurization. Batch holding or low temperature long time method and continuous high temperature short time method. In the batch method, the milk is heated to 63 degrees Celsius in a tank or vat equipped with a hot water or steam jacket and agitators to keep the milk agitated, held for 30 minutes and then partly cooled in the batch pasteurizer. The further cooling is done by surface plate cooler. This method is mostly used for processing of around 5,000 liters of milk. High temperature short time pasteurization is the process which is commonly used nowadays all over the world. Plate heat exchanger is used to heat, hold and cool the milk. Milk is heated to a temperature of at least 72 degrees Celsius and held at the temperature for not less than 15 seconds and then immediately cooled to a temperature not greater than 4 degrees Celsius. Test for pasteurization efficiency. Phosphate test. Phosphate test is done to determine whether milk has been properly pasteurized or not immediately after the pasteurization of milk. The test is based on the principle that alkaline phosphatase, a natural enzyme present in the raw milk, is simultaneously deactivated by heat treatment as specified for pasteurization. When milk containing phosphatase is incubated with p-nitrophenyl disodium orthophosphate, it hydrolyzes the substrate and as a result para-nitrophenol is liberated, which gives a yellow color under alkaline condition for the test. The amount of yellow color present is directly proportional to the amount of phosphate present in the milk. The process of yellow color indicates inefficient pasteurization or post-pasteurization contamination of the milk. The intensity of the color is compared with standard and Lovibond comparator disc. Homogenization. Fat globules in the milk normally vary in size ranging from 1 mm to 22 mm with a mean size of approximately 3.4 mm. As the density of milk fat is less than that of skim milk, the fat globules tend to rise to the surface during the storage and form a cream layer. Homogenization with reference to milk dairy applications refers to a mechanical process that is used to reduce the size of fat globules such that milk fat does not rise to form a cream layer during the storage of milk. Although homogenization renders fat globules uniformly distributed in the body of the milk, upon prolonged storage, it does not remain completely dispersed. Homogenization is a mechanical process in which milk is forced through a homogenization valve under the very high pressure. The milk is thus deflected at right angles through a narrow opening of about 0.1 nanometer. As the milk comes out of this valve opening, there is sudden drop in pressure and the milk is subjected to impact against an impact ring. The complete process results in disruption of flat globules, leading to decrease in the average diameter and an increase in the number and surface area of fat globules. Definition of homogenized milk. United States Public Health Service states that homogenized milk is milk which has been treated in such a manner as to ensure breakup of the fat globules to such an extent that after 48 hours of quiescent storage, no visible cream separation occurs in the milk, and the fat percentage of the milk in the top 100 ml of milk in a quart bottle or of the proportionate volumes in containers of other sizes does not differ by more than 10% of itself from the fat percentage of the remaining milk as determined after thorough mixing. In single-stage homogenization, up to 6% fat milk, usually a pressure of 2000 to 2500 pounds per square inch is sufficient. For milk with more than 6% fat, two-stage homogenization is used to prevent fat clumping. A pressure of 2000 pounds per square inch at the first stage and 500 pounds per square inch at the second. Sterilization. Sterilized milk refers to a product obtained by heating milk in a container in a commercial cooker, retort to temperatures of 110 to 130 degrees Celsius for 10 to 30 minutes. The process is also referred as in container sterilization. Sterilization milk is generally intended for prolonged storage at room temperature up to 6 months. The major objective of heat sterilization is to destroy microbial and enzymatic activity. The length of time and magnitude of temperature employed during processing depends on the type of product, number and heat resistance of microorganisms and enzymes present in the milk. The heat resistance of microorganisms or enzymes is generally evaluated in terms of D value or Z value. Sterilization load or heat load of sterilization is generally expressed in terms of FO value. Theoretical basis. Clostridium botulinum is considered as the index organism for accessing thermal sterility in foods. Therefore, destruction of this organism is a minimum requirement of heat sterilization. As milk is low acid food, it's recommended to achieve 12 decimal reductions for C. botulinum. Those spores are not pathogenic. Their presence may require heat treatments equivalent to 2 or more decimal reductions. This may correspond to an FO values of 8. Target spoilage rates should be less than 1 survivor in every 10,000 containers. Types of sterilization plants. Sterilizing retorts are either batch type or continuous in operation. Batch type sterilizers may either be vertical or horizontal. Horizontal retorts are easier to load or unload. Cans are loaded horizontally into the annular space between the cages. When the cages are full, the retort is sealed. The cages are supported by guide rails which slowly rotate them. The stirring of the contents in cans facilitate proper heating. Continuous retorts are generally equipped with better controls. They cause very gradual change in the pressure inside the cans. Thus, products are heated more uniformly. Can seams are also subjected to less strain in comparison to batch process. Continuous sterilizers. They are mainly of 3 types: cooker coolers, hydrostatic sterilizers, and rotatory sterilizers. Cooker coolers carry cans on a conveyor which pass through 3 sections of a tunnel. These sections are maintained at different pressures for preheating, sterilization, and cooling. Continuous rotary sterilizer consists of several horizontal interlinked cylinders which allow for preheating, heating, pre-cooling, and cooling in up to 4 continuous stages. Rotatory sterilizers are particularly suitable for processing of milk and milk-based products which are extremely heat sensitive and susceptible for browning. Quality of sterilized milk. Sterilized milk has a rich creamy appearance and a distinct cooked flavor, rich, nutty, caramelized. It's considerably browner in color than raw milk. The brown color develops due to the formation of colored pigments resulting from interactions between the free amino groups of protein and aldehyde group of lactose through Maillard reactions. The intensity of cooked flavor and brown color depends upon the severity of heat treatment. In container sterilization causes loss of nearly half of ascorbic acid and seizable loss of thiamine. Vitamin B12 is almost completely destroyed. Fat-soluble vitamin A, carotene, riboflavin and nicotinic acid are not affected. Biological value of proteins is only marginally affected. Sterilized milk cannot be coagulated with rennet unless calcium chloride is added externally. UHT processing. UHT milk can be defined as a product obtained by heating milk in a continuous flow of a temperature in excess of 125 degrees Celsius for not less than 2 seconds and immediately packaging in sterile packages under the aseptic conditions. In India, UHT milk is generally processed at 140 degrees Celsius for 2 seconds. Theoretical basis. Heating of milk results in the death of microorganisms, while some bacteria are destroyed by pasteurization only. Some survive this thermal treatment. Bacillus subtilis and Bacillus stereothermophilus spores are very heat resistant. Of the two, Bacillus stereothermophilus spores are most heat resistant. It's therefore considered indexed organism for evaluating performance of UHT processing. In the temperature range of 100 to 120 degrees Celsius, time required for death of almost all B stereothermophilus spores are more. This may therefore result in more browning in the product. However, if milk is treated in the UHT range, that is 135 to 150 degrees Celsius for only few seconds, almost all spores may get killed and browning would be minimum. Loss of nutrients and total quality also will be minimum. A product processed in this temperature range will be thus microbiologically safe and yet superior in terms of overall quality. Types of sterilization plants. There are two types of UHT plants, direct type and indirect type. In the direct type, plants heating is done by mixing product and steaming. In indirect type, plant product is heated by steam or hot water without the two coming in direct contact. Heating in direct type plant is very rapid, particularly between 80 to 140 degrees Celsius, and total heat load is less. Changes in the product quality are therefore minimum. Aseptic packaging. In aseptic packaging, UHT processed or sterilized milk is filled in pre-sterilized containers under aseptic sterile environment. This ensures that there is no post-processing contamination of the milk so that the product has no longer shelf life. Before the start of product packaging, trial runs also routinely conducted with sterile water. The seal integrity of the package and overall microbial quality of the packaging material are monitored properly. Generally, for a good processing plant, permissible spoilage rate is 1 in every 5,000 sterilized, filled and sealed package of 1 liter carton. Sterilizing mediums, two categories: physical sterilization mediums and chemical sterilization mediums. Physical sterilization mediums. Steam under pressure or hot water is the most simple and reliable sterilant for high sterilization efficiency in short time. Its use is, however, restricted to sterilization of the milk tubes and valve and fitting coming into product contact. Dry heat superheated steam air, ultraviolet radiation, optimum wavelength 250 nm. Ionizing radiations, gamma rays, usually 2.5 mrad intensity, is suitable for sterilizing plastic laminates used in aseptic bag in box. Chemical sterilization mediums. Ethyl oxide, used as a pre-sterilization agent to reduce microbial load on packaging films. Hydrogen peroxide. Hydrogen peroxide is the most popular sterilant for aseptic packaging system. Type of packaging materials. Metal container. Cans made of tin plate or aluminum are generally used for packaging of condensed milk, viscous liquids. Laminates cartons. Different layers of flexible films of different material with paper, polyethylene and aluminum foil are co-extruded to form a laminate. Plastic films, black and transparent polythene films are co-extruded for packaging of UHT processed milk intended for 2 to 3 weeks shelf life. The co-extruded film protects the product against light but not the oxygen. Simultaneously, extra polythene strip is heat bonded along inside of longitudinal steam. This is done to prevent fill product penetrating the paper layer. As this continuous cylinder moves downward, jaws at the bottom make transverse heat seal. The product is filled instantly and another jaw seals the package at the top. Depending on the type of machine, different shapes can be given to the package. The most popular is brick-shaped package. Tetrahedron shapes were also being used. To cut down on costs, some dairies have introduced pillow packs for packaging of milk. With this, we conclude today's topic. Thank you for watching.